Okay, so let's try to continue on the game that we were doing in the cool language. And yeah, as we decided, I guess let's try to build a snake game, right? I think that's the interesting thing to do here. So I have this game.cl file, and yeah, let's continue with it, right? So yeah, I have to remember what I did here, right? So of course my idea is to have a linked list for the player, which is gonna be the snake. So let's see how we are gonna do that. So we're probably gonna have a class snake, right? And I guess we might need although I think we can have the position left, you know, for the list itself. So we might have a class snake cell, right? And the snake, as I said, is going to be a linked list, and we already have a list.cl which has some functionality for lists. For example, you can append stuff to it and get the value out, also iterate it, so that's gonna be useful. So let's say cells is gonna be of type list, right? And we can leave it, I guess, out for now, or probably I mean, we are gonna have an init function that returns self type, right? And this method is gonna initialize the snake, right? So we are gonna do something like cells is gonna be equal to a new list, right? And inside of this list we can append stuff, right? So we can append stuff and we can also initialize it. So I think it's easier to use init, so it's gonna be like init, and let's see, how about the init function of the snake getting in the position X and position Y, the same way we do here. Maybe also the cell sizes. So, right, I feel like the snake itself should have size X, size Y, keep the sizes, the cells, and the cells probably should be X, or maybe position X and position Y. So yeah, as I said, here we are just gonna initialize the snake cell. So let's do init just like this. I think this looks good. So init is gonna be just a new snake cell, and we initialize it with this. And then for the tail of the list, we kind of have to use a let void is gonna be list in this thing, and then use void here. And yeah, we need to do this because the list is terminated by a void, right? So at least that's the easy way to do it. We know that the list is over when we find a null, and in this language you get null if you do something like this. When you initialize a variable and you don't do any value to it, it's gonna be null. But I mean, that's true only for custom, I guess, like object and stuff like that. But just to keep the type checking fine, we have to use list. See, like here we use list. for the n argument. So yeah, this should probably initialize the cells, right? Then we initialize the size of each individual cell, but I want to keep the size here. Well, I mean, it could be interesting to keep it on the cell and have you know, when you eat something, it does like an animation, you know, the belly of the snake gets fatter. Yeah, no, let's keep it simple and keep the size here. So now we are gonna have a render method, and I think that the render method should probably get in ArrayLib. Right, you should get in ArrayLib, and it draws a rectangle, the position, and here I guess that this render method is not really that important on what you return and stuff, so I guess, yeah, let's put the size on the cell itself. Let's actually make it simpler. Sy. So I mean, no, because I just wanted to have this render method be as simple as possible, so this should be size x, size y. Right, so this is how we are gonna render a cell. We just draw a rectangle at this position and this size, and with color black. I mean, this is hard coded for now, but I think it's fine. And when we are trying to render the snake, it's gonna take in ArrayLib. All right, this is not good. So how it's gonna work is we are gonna have let iterator is gonna be equal to cells, although I don't think we need an iterator. I think we can just use cells themselves, but you know. So we have the iterator, right? And now what we need to do is a while loop. So let's do a while not is void iterator. We are gonna loop and then we are gonna pull. I think this can be indented like this. Right. Well, yeah. Okay, so basically we need to get the value out of the list and call render on it, but the issue is that if we take a look at how value works, it returns an object, doesn't really return. So if we do object value, this returns an object, so we kind of have to cast it in some way to a snake cell, and we can do case of cell snake cell. We just call render on that cell, right? And this is esac, and here we need semicolon, and yeah, this should be like that. So yeah, and I think we can keep the case simple only with the snake cell case, because the list is gonna contain only snake cells. Like, we're gonna make sure that that happens. Right, so I guess afterwards, after we call to render, we also have to specify that the iterator goes to the next cell, and then we repeat the loop. So yeah, I think this should probably just render the snake, right? Okay, I think this should be good enough. Okay, so let's see. Yeah, sure, we're gonna have the screen width, screen size. I guess this is the player size. Let's have something like cell size is gonna be 50, and then we're gonna have snake cell size. We can make it like 45 just to have some padding around the cells. I think that will look nicer. Right, we create a new raylib. Here we create a new player, but I mean, let's just, remove the player or something, even though I would like to reuse some stuff. So let's say snake is gonna be a new snake. And sure, I would put it right in the center. Oh, yeah, sure, when we draw this, I think we need to center it. I think it will look much better if we center the cells. But anyway, let's see. So this one, usually I think the game starts from the center, right? So let's do screen width divided by 2. I think this looks good. Then let's just keep the snake for now. The name of the game is gonna be Snake. Sure. Oh yeah, and I said I might add time to... probably I'll add it just to make the game more random, but for now, random seed 42, right? I mean, whatever. Then we have this loop for the raylib while the window should stay open, basically. Wait, why did I not do like that? So first of all, yeah, we should have an update method like snake.update, right? Then we begin drawing. We clear the background with white, and then we do snake render. Right, although let's call it draw because I don't know, it's more raylib like. So I guess we can try to test if this runs. We can make the examples just to, although as I said, build, or it's like cool. Just like this. And here it's gonna say undefined method render, because here we need to call to draw, right? On line 103 there's something else that we need to do. Yeah, return raylib. For some reason I wanted to do it like that. And we also need update. So update, what does update do? So it's just gonna do nothing for now, I guess. Update raylib, let's say it returns raylib. So for now it doesn't do anything. Okay, so I see that, right, we have the snake cell. Perfect. I think now the snake should have a direction, right? So I mean, the direction is pretty weird. I think it's easier to say, to have something like speed. Right, and yeah, I mean, it can work like a direction X and direction Y, although it's more like speed or what, it's right. I guess there's not really a rule for it, so let's just say this one is gonna be 1 and this one is gonna be 0. Right, in the beginning it's gonna start going to the right or something. So let's see, something like this. That's why I wanted to keep that, just to be able to, you know, steal from there. Right, so we do a block. And I guess depending on your direction, this behaves differently. So like if you press A and you move and like speed Y is like 1 or -1, that's when it takes effect, otherwise it doesn't. So yeah, I guess we have to hard code all the cases. I think that's the easiest way to do it. So and speed Y is equal to 1. Then what do we do? I think we need to do two things. We need to put the speed X to -1 and speed, yeah, I think, let's see. If you press D and you move up, perfect. I mean, come on. If you are moving to the right and you press W, it has to go up. Perfect. Well, speed 1 here, it means that you move down, actually, I think. So if you press A, yeah, I think it's fine. Okay, and if you press S, but there are also some other cases. There's the case if you press A and speed Y is well, we don't have -1, we have to use this thing. So yeah, that was okay. Yeah, that's the really weird key to press. Okay, so if you move down, right, and you press A, you have to start to move towards the left. If you move down and you press D, you move towards the right. Okay. Then for W, it's if you move towards the right and you press W, you go up, and if you press S, you go down. Then let's do the same, but actually I would move this one here, like it's the pair of this one. It's the reverse, I wanted to say. So if you are going up and you press D, you should actually go to the left. Then we do the same thing for W. If you press W while you go to the left, you should go up. Wait. If you go to the right and you press W, you go up. And if you go to the left and you press W, you go up. That's interesting. Anyway, if you press S while you are going towards the left, yeah, this is pretty strange. Let me see. I mean, we are gonna test all the cases manually, but it feels weird that W and S are the same, but these are different. So if you are going from left to right, and you press W, the snake should go from, moves up. And if you go the reverse, yeah, it makes sense. And if you press S while you go on the x-axis, it should go down. So it actually makes sense. Strange that it makes sense though. And here we close all the ifs. It looks like it's a table. So weird. So let me just see the A case one more time. So for the A case, if you go, let's say, in the down direction, if you press A, you should start going. Yeah, I think regardless of the direction on the Y, if you press A, you always start to go to the left, and if you press D, you always start to go to the right. Yeah, I think this is how it should be. So should we update the position before the input or after the input? That's a good question. I mean, why not? Let's do it afterwards. So again, we kind of need this thing, right? So let's do a set, or I guess we just need a set, like set position, and this is gonna take in other snake cell, right? And it's gonna return, well, that's not gonna work. We need pose x as a function and pose y as a function. So something like this. All right. And as I was saying, we need this. Let's put it here. So we are gonna iterate over all the cells, right? Iterate over all the cells. And sure, we take the value. although sure, here we can just say x, just make it more simple, but we still need this stuff. So yeah, basically I mean, sure, we are always gonna have a head, which is always gonna be case, right? It's always gonna be available to us. So let's take x is gonna be head position, right? This is the new x, so let's call it like that, new x. But x is gonna be just the x position, or call it head x. No, let's call it x. So this becomes x, and then y is the same thing. Let's just move it like this. So the next next thing that we need to do is to actually update each cell, right? So we are gonna iterate all the cells. All right, we iterate all the cells. Let's make another let snake cell is gonna be equal to this thing. So let's just forget here about semicolon. So this will give us in, right? So what can we do in this one? I think we need a block statement, right? We need to do some calculations with these guys. So x is gonna be equal to the cell position x, y is gonna be this thing, then we do set position to new x and new y, and then we take new x and new y. I think that's good. Okay, let's see, let's go through the compilation errors first. Jesus, 137. Oh, I don't see the error. Oh, okay, size x and size y. So here let's also do size x, size y. Now let me just remove the old player class, we don't need it anymore. Yeah, also let's delete. Let's delete the coin for now, it's easy to implement it anyway. Oh, so it just compiled. Yo, it's a bit too fast, but kind of works. Let's I guess let's make the game run at less FPS, like 12 FPS. What is still so fast? Let's do 3 FPS. Okay, I don't get how is it so fast. Does it not care about that? It's pretty weird because I thought that set target FPS. Actually, I don't know, it seems like it's working. But I mean, it's not ideal. So let's say that the FPS is still 30, but we only do update, like we only update the cells like every, I don't know, 30 frames or something. So let's keep here a frame counter is gonna be 0, and move frame is gonna be, I don't know, like 20 something. Like, let's keep it really simple, let's not overcomplicate with time, delta time. So let's take this thing out. Let's have an extra function, move snake is gonna return object. I don't care about it that much. So let's see. I think this doesn't take any arguments, it's just on self. It should probably work. Here let's do frame counter. If the frame counter is move frame, then it moves, but doesn't matter. 104. So on this one it wants an else 0 fee. So yeah, now it and it actually takes the input. Right. Oh, if I press, yeah, I see. Yeah, like if I press multiple keys at once, and it can go like in circle, it circles back on itself. So I guess this should be somehow buffered in a way. You know that, well, you press this key and only inside of this it actually does the direction switching. Right, something like that. So let's have pressed A, W and S, right? And I guess we need this stuff. Let's remove the duplicated things, and here we don't care about the speed, right? We just want to say pressed A is equal to true. Here we say press D, and you know the drill already, so pressed S. And this will basically just keep the key presses as some buffers, whatever. And now we have to change here this part with pressed A, for example, right? Something like this. You know, and let's just test that it will still work, I guess. Press D. Press W. Right, so basically we just you know, reset the keys afterwards, and if we try to rerun this, it works the same as before, but with the same bug here, that if you press W and instantly D, it switches directions. So to fix that, let's take this entire stuff and put it inside this if. So basically we keep track of what keys were pressed, I guess, and yeah, only afterwards, like only if these conditions are met. Yeah, I don't know, if you press multiple keys at once, it probably will do something weird, but let's see. Like if I spam the keys, I mean, it will take the first key that you press, right? So if I press S and D at the same time, or you know, yeah, if you press multiple keys, it will take the first one that you press. So I think that should be good, probably. Like it looks okay-ish. So let's add back the coin stuff, right? So class coin, and it's gonna have, yeah, it's gonna be, I don't know how it knew, took it from before. So let's do coin.draw. Alright, so it's on line 156. Oh, these should be ints. I don't know why it tried to be useful. Oh, there's no red. I mean, how is a coin red? I guess it makes sense for Snake, but for okay. And what we, oh yeah, I forgot about that. We have to actually see where we draw this thing. But I think 100 should be fine. Let's think about it. So the center of the first thing will be at 0 0, obviously, then 50 50, 100 100. So no, it's 25 25, but yeah, pretty strange. So this is the cell size. Oh yeah, actually I know. It's because Snake takes like this, but it also needs cell size. It also needs the cell size. Right, so size is gonna be an integer, and here we keep the size. So we no longer need these. These are just for drawing, right? Just for drawing. And when we actually do the movement, where is move Snake? It's gonna be cell size, right? That's how it should be. All right. And in init of the snake, we need to add cell size. So yeah, I think now it should be aligned. Yeah, perfect. So let's make, I guess, the snake eat the coin. I guess, you know what, I had that logic somewhat implemented inside of the coin. So let me just yoink it from this. Like, it should be just, you know, a bit of a logic. Although yeah, I think it's gonna be easier to just do it. So update is gonna take in, let's see, update should, I mean, usually it takes in only raylib because it doesn't have any logic, but let's say enabled is gonna be set to false initially, right? And in update, if, let's just use only raylib, just say that, and here if not enabled, then we take a random thing and we return raylib. So I think that should be it for this class. So if we, no, wait, actually we have to call to update, coin update. Ooh, 162. So I think I forgot to add this thing. Yeah, wow, it's, yeah, so now it's moving it randomly. Alright, because I forgot to set enabled to true. So if we try it again, it actually it displays the thing in a random place, but the issue is that it's always going to be in the same spot because we don't have a real random seed. So I'll do that after we are done with the logic for the rest of the stuff. So yeah, let's I was thinking, how about making a vector2 class, and we can define all sorts of things on vector2, but I don't really feel like it. Although yeah, I don't know, I feel let's keep it like x and y. Why not? So here we should have pos x is gonna be the getter for those attributes, and let's also say consume. It sounds really menacing. I mean, it shouldn't really do anything, so it can be self-type. So let's do it like this. Basically, its purpose is to reset the coin in some other place. So now let's make another class game, and like I could put the eat logic inside of the coin, but I would put it I would rather place it in another class for some reason, I don't know why. So this one will have a reference to the snake and a reference to the coin, and in update raylib it shouldn't really do that, but yeah, what it should actually do is check if the positions are the same. So let's make a function in this one that's gonna give us the head position X and head position Y. So it's gonna be something like head pos X, right? So how it's gonna work? This can be cells, so it should be simpler than that. It should be something like this. So it's cells value, which is the head. If it's a snake cell, it's always gonna be a snake cell. It does pos X, and head pos Y is gonna be like this. Head pos Y. Okay, so what we have to do now inside of the update is if let's say snake dot snake pos Y, then coin consume, but we also need to do coin dot consume, but we need a function for snake dot grow or something like that. So we need this thing here, right? Snake grow. Let's go on the snake and add a grow function somewhere. So basically grow, let's say return self type, because why not? This is gonna be interesting to implement. And then we have to implement the eating of itself, basically. So yeah. Let's see, let's just do self, just self for the moment. See if we have any bugs. So 193. Wait, what? Expected then. Oh, because and is actually a function for me. Okay, let's put this thing down, this thing here. Okay, I think this looks good. Let's keep it like that. Okay. Snake pos. I think it's head position. The head. Right. So nice. Build gain. So now if we try to actually eat, yeah, sure, we didn't actually. So let's do game, right? New game dot init. We pass in those things, and I guess we can also try to update these two guys. We'll see where we have to do the update. Right, and here we can game update, and whoa, what the, and let's also do a draw, which should just, how about also doing this stuff. Right, like, let's just do everything, I guess. Game draw. There is no init. There is really not an init. I really like how Copilot already learned the language from okay, all right. I mean, another thing we have to do is to not allow the coin to spawn like on the edges, right? So let's see. So the map size, so let's put inside of the coin, let's put a min x, max x. I mean, they can have initial values, why not? mx is gonna be an int, mx, oh, that won't work, xm, xm, let's do something really beautiful like that. I mean, it's okay. So this is the initial position of a coin, but I would actually set it to being consumed at first. So let's say it doesn't matter the initial position, right? And I guess min x is gonna be 0, max x is gonna be 6 or something. Oh, it's 8. Right, and screen width is gonna be max x times 100. Well, it should be times cell size, so that means that this should be 16 and this should be 12. So times cell size and times cell size. Coin radius. New float from integer. So this is gonna be like that. So yeah, okay. Although for this one I would say maybe, you know, do +1, -1, +1, just to not hit the border, right? Just to not hit the border. Let's say consume. Let's make it consumed at first. Right, so I guess we also need cell size in here. There's so many things in the constructor. I just wanted to see how I called it in here. So size, I wanted to keep it, you know, cell size. So this should be min x times cell size, and yeah, just like that. Let's see some compiler errors. I guess in here we need to specify cell size or something. Yikes. I'm wondering what segmentation fault did. Oh, this is pretty bad. Okay, let's go back, see what happens if we only do this part, right? And if we don't initialize the XMs. Alright, so maybe it's, I don't know what it could be though. Okay, let's do cell size is gonna be initialized with something, but I would prefer to have here size, at least size. Oh, it's because I overwrote size. Let's say this is radius, but that shouldn't happen. Or I guess, yeah, I know why. It's because this is a float and it was null, right? So that means we can actually go probably. Oh, that's why you actually want to handle exceptions. Although I don't do that. So this should be called radius. Or I guess that's why you want to have, I don't know, an LSP, I guess. So this should be radius. Let's see. Okay, so now it should be random, but inside of this screen, never on the edge. It looks like the stuff works. Sure, we have to, I don't know, what do you think it's cooler, to have the snake wrap around, or to, you know, just die when it hits the edge? It edged too hard, so I guess let's do grow first. That's what we were working on. So basically, in the growing, we have to iterate the snake. To be honest, I would do the same thing as we did here in a move, and you'll see why in a second. Basically, we have the head, right? And we take the head position and also the new x and new y. But new x and new y, it's a bit yeah, let's say like that. Let's say that because we just want this for the reverse direction, if you know what I mean, like the reverse speed of the current cell. So we take the head position, right, and we need the previous position also, or instead of previous position, let's say the position of the next cell in line. But if we have only one cell, we don't really know, so we actually need the speed of the current cell, or I mean the last cell, something like that. And to get the speed of the last cell, we can take the next cell and subtract this one. So let's see if I can do it actually. So here we take a cell, right? But actually let's put here cells. All right. So because I wanted to skip the first one is not important. Dot next. So we have to go until we are on the last cell, right? We go until we are on the last cell, and what we have to do on each step damn it, it's a bit difficult. I wanted to say that when we are on the, like on any cell, let's imagine that we are on the third cell or something, we have the x and y of the cell, right? We have new x and new y which are for the cell ahead, so we can take the offset by doing new cell minus x, new y minus y, right? Like that's the offset. I guess that's the direction where the current cell wants to move, so that's the speed, and we need the reverse of that. So basically what we actually need here is let offset x is gonna be an int, and it's gonna be x minus that in, and here we need to say like now we just need to do x plus this, so cx is gonna be x plus offset. So it's weird, but it's like x to x minus new x. Is that a thing? So strange. That's how it works, right? That's so weird, and it actually makes sense. Yeah, anyway, so basically what we need to do in the in is to iterate. Well, we don't need to do anything. Wait a second. Yeah, we just need the offset, and we need to compute these here. Is that so? Yeah, I guess so. Cx is gonna be 0 at first, and cy. And I think we just need to compute cx is equal to x with x plus x minus that and cy. So I think this is how we take, because x and y are the position of the current cell, right? So we take the position minus where the cell wants to move, the position minus where the cell wants to move, So if it wants to move to the right, this will be -1. So it goes to the left 1 step. And I guess here we actually need this kind of stuff, right? Let's just ident it once to see that. And here we need to create a new cell and append it. So if we go into list.cl, we have here append. So we just need to add, so we need to do iter.append, right? We need to iter.append new snake cell init. I think that's good. Cell size. Wait, I didn't save these two. Snake cell size X, snake cell size Y. Snake cell size, because yeah, that's what we actually need. So I think this should do it. Type list. Oh, it should return what? Self type. Grow. For some reason, yeah. For some reason it should return self type. Whoa. Bruh. Alright. Holy shit. Bro, it actually works. It actually works first try. Not even joking. How is it even possible? Bro, can I be this lucky? Like, the first cell was a bit scuffed, but afterwards, like, what the hell, it actually works. It actually works first try, like, well, I mean, you cannot eat yourself. It's like Slither.io, it goes crazy with the overlapping. But it really is amazing. Like, it is scuffed, but yeah, it actually works. Anyway, I want to see again what happens when you take the first cell, because it was okay. You have to be careful not to go. Interesting. So when you take the first cell, like, for a brief second the cell is in a really bad position. So let's imagine how this goes, right? So X is gonna be the position of the head, new X and new Y is gonna be the position where the head wants to move, right? So we find out, okay, yeah, perfect. I think I know that. We have to initialize this with X like this, because for the head this will never execute. It right, it never executes. So it jumps straight to here, and CX and CY are 0 initially, so we have to initialize them. So this should fix that. Yeah, it fixes it. Perfect. So now we actually have I I mean, yeah, sometimes it's scuffed. Okay, so let's try to reproduce that. It looks like it looks a bit strange how that happens. A bit strange indeed. So I guess like new x and new y is gonna be the position of the previous cell, right? Is gonna be the position of the previous cell. X and y is gonna be the position of the current cell. So if we, for example, look at the last cell, it doesn't make sense, to be honest. Why it wouldn't work, I don't know. Like, it's so pretty strange and scuffed. So if we do something like that, yeah, I really cannot think about it. Like, it looks so weird. Oh my god, like I really cannot figure out why that would happen. Like, it's always for the last one. Like, not really the last one, but it's it's weird, right? Like, it generates the cell not after the last one, but after the one before the last. No, like, that's what I see, but I don't really know why or how. Because it has to go through all of them, so yeah, pretty strange. Well, I mean, anyway, it's probably something to do with the order we update stuff. So let's maybe try to do that first. So maybe this makes more sense. Like, it stays in oh my god, I managed to get it again. Yeah, it's always on the last, if you make a last turn or something like that. Yeah, I don't know how to fix that, so we are gonna ignore it. It's like a visual glitch, it's not important. So let's see how we can make the snake eat itself. So it's gonna be a dead function, the dead. So it's gonna return a boolean. and it should follow a similar logic to moving and doing all of that stuff. Like we need this, right? We need this stuff. So basically we take the iterator, we take the head, the position of the head, and that's all we need. So here let's say cells, and I'm gonna change that also in cells just to not forget about it. Cells, just to not interfere with the iterator. And I would say that this one should be next. Actually, we don't care about the one. Okay, so we iterate all the cells except the first one. So we iterate the tail basically. Here we take the current cell, right? And let's do here a variable d is gonna be false, right? We take a cell, and here we need to do something like dead is equal to dead or this stuff, right? So basically if x position is equal to y position, wait, what the hell did I say? If x is equal to x and y is equal to y, then it means that the head is on top of a cell from the body, and we have to do an OR here to keep the, like if you are dead, it stays dead, right? So this is gonna be D. I mean it can also be called dead, it's not. So dead becomes true. And yeah, I guess at the end of this thing we need to return dead. So yeah, I think that's how the check should be done. So obviously if we go to the game class, right, we can do something like if snake.dead, then well, not really sure what to do though. Like, do we just close the window straight up? Or maybe this should return like a boolean. Maybe it can return a boolean. So here at the end we can say snake dead. It can be like a not snake dead. Not snake dead. So update returns, you know, boolean. So I guess we can have a game over boolean variable, right? It's gonna be false, and I mean, let's keep it simple. So no, it's gonna be keep running through, right? So not this thing, and keep running, right? Yeah, and keep running is gonna become this game. So basically if we eat the snake, so let's see if we try to brights. Okay, it didn't work, I guess. or what? Okay, it actually worked. I guess it was too short. Okay, so Snake Dead, it's happening after the update, and that's before drawing, so I think it's fine. Should we maybe keep a score? I guess score is equal to 0, and here score increases. So in draw we can actually I really like that you tried, but you have to use concat. Let's see if drawing the, yeah, because it's toString, because it's toString with the, okay, so it's that's actually the number. Okay, so score toString doesn't work. What? Okay, that's strange. So in prelude.cl, when we do toString on an integer, why does it look like that? That sucks. So in examples, let's see if we have main.cl. So class main is gonna return like an object or something. So let's do, new IO. New IO, and let's do out string hello world. So all examples main. Share friend, yeah. Oh, and now it's in examples main. Wait, where is it? Oh, it's in main. Hello world. But if I do 0.toString, what do I get from this? It's 0, so it's fine. So if I do 50, it's 50. Then why does my game look so weird? So if I do, let's say we do score.concat and try to do that's strange. Yeah, that's a bit strange though. Not sure why it looks like that. Let's do a new IO here, new IO dot out string, and let's also print it to the standard output. Let's print it to stdout. Okay. So it's score 0. Oh. What? Why does it put an A at the end? That's interesting. Like, see, it looks fine without string. Like on std out it looks fine, but why is there extra stuff at the end of the string in Raylib? I guess that's concat. Let's put an empty string like that. Let's see if that helps. Doesn't help. So maybe there's an issue with how I do concat. Not really. Who knows? Let's do a new line randomly. Okay, this fixes it. So yeah, I guess it's an issue with toString or something. But now we actually have a running game inside of cool. Yeah, it's a bit scuffed at the end. I don't know why, but no, it's when it's adding the new what's it called, the new part of the snake. That's when it's a bit scuffed. So yeah, I guess, I don't know, maybe if we try to do update, like update the snake before, maybe that helps. No, it doesn't. So funny to go out of the screen. Yeah, I don't know how to actually fix that issue. But I mean, the game is still playable, so oops, and we died. Okay. Yeah, to be fair, I don't know how to fix that, so I guess it is what it is. Yeah, and I was thinking of wrapping around the snake. Let's see. So basically, I would copy paste the minimums from here. So let's copy paste these guys, and I guess the minimum should only be applied on the head, because if you apply it on the head, it's easy, you know. So let's do something interesting. Let's put these things here. Let's come in init and let's initialize them. Right. Now this thing should be here, just in case. I don't know what Copilot did there, so just to be safe. So yeah, now we have min x, min y, and so on. So here when we damn, let's maybe have a function for new x and new y. Right, let's maybe have a function. Let's maybe have a function. So new x, ew y, and new y. So it's gonna be like this, right? So now My guess is this needs to be new x, new y. Do we even need a head? No, we don't. I don't think we need a head. Do we need a head here? I don't think so. So we can just... Whoa, actually we do. For x. Head pose x and head pose y. Now we don't need it. Perfect. So this turns into like that, and this is new x, new y. Okay, something like this, and then we don't need it. All right. So what I'm thinking is like if this becomes negative, let's have let x is an int is equal to this in. Right, so if x is smaller than that, then it goes to max x. Yeah, I like this. I think this is good. So if x is smaller, then it wraps around. Else, I like to have yeah, else if this, then that, else x, and we need another phi. So I think this is how we do it. Let's see if Copilot, yeah, good job, little buddy. Okay, so ew. Alright, so this should be max x is smaller than, because we don't have the greater than operator. So okay, init, so init in this case, don't know, I think I want it to be with -1s, because why not? Let's have like a border around the snake. So now if we go out of screen, it should wrap around. Let's see if it works with Jesus. It actually works, like again, first try. So I think I see something that I don't really like, and that might have to do with the fact that here it goes into it, right? It goes into it, and here it comes out. So let's think. So I do either change this to smaller than or equal, right? Smaller than equal, and I think this makes more sense than changing anything else, because usually okay, and I guess I just have to, but why does it, wait, what? Even though I put smaller or equal, it behaves the same. That's really strange. Okay, anyway, let's do the next best thing, which is to increase. Whoa, no. It's +1. That's why it didn't work. It's +1. Alright, so yeah, this looks better. Maybe we have to add a border just to make it more obvious that you go out of bounds or something. But yeah, that's pretty nice. Now the snake wraps around. You don't have to worry about the, you know, Jesus. Yeah, we actually have a snake, and I mean, you know, the next step is to make it work in WebAssembly, but no, let's, now that would be painful. But yeah, you can see that it actually works. Sure, now the spawning of the coin is not perfect, and the tail of the snake sometimes it bugs out, but other than that, it is a snake. Okay, I cannot take that one. Push it out. Yeah, sure, it's a bit scuffed on the control side, but I undershoot basically. But yeah, I guess this was it for today. I actually managed to get like done with the game. I thought that it might be a bit difficult, but it actually was pretty easy. So I guess what we did was only this file. Let's see how many lines of code we have. 350. Yeah, I would say that I don't know if probably it will be smaller if you do it in C, but I think it's pretty nice. Like, we got pretty good results. So yeah, I'll just, you know, this will be also part of the compiler, so it will be in the same repo. Added snake game, if you want to play with the snake game. So yeah, I guess that's all for today, so I'll see you in the next one.